Now let's look at geometric proofs. And again, these will be two-column proofs. Here's what we want to do. First, we want to write the conjecture to be proven. Second, draw a diagram or sketch to represent the hypothesis of the conjecture. State the given information. Mark appropriately on the sketch. Plan your argument. You've got to figure it out. Use your deductive reasoning skills. And 5, prove the conjecture in as many steps as you need. Our first geometric proof will be to prove the linear pair theorem, and this is on page 110. So here's what we're given. Here's a sketch of the given information. 1 or 2 are a linear pair. We want to prove that these are also supplementary. So first, state my given. And now I want to keep in mind what I'm trying to prove, that these two are supplementary. There's a definition of a straight angle, which shows that these two angles combined give me 180 degrees. So I'm going to start by defining a straight angle. In order to demonstrate a straight angle, I first have to explain that we have a line. So opposite rays form a line. And that's part of our definition of a linear pair. And now I want to give a measurement to this straight angle ACB, and I do that with another definition. Next, I'm using a postulate, the angle addition postulate, telling me that angle 1 plus angle 2 equals this straight angle. Measure of angle 1 plus measure of angle 2 equals the measure of angle ACB. That's the angle addition postulate. Remember, in our justifications column, we can use given information, definitions, postulates, properties, or previously proven theorems. Next, I'm going to substitute. Measure of angle ACB is in each of these lines. I can do what we would also consider the transitive property. If 180 equals ACB and ACB equals 1 plus 2, 180 equals 1 plus 2. Oftentimes, substitution and transitive property are interchangeable as an explanation. And my last step is our conclusion, which is what we were trying to prove. And we've done so with our last step of justification, which is the definition of supplementary angles. Our next proof will be for the congruent supplements theorem. This is on page 111 in your book. We're given that 2 angles are supplementary, 1 and 2, and we're also given that 2 and 3 are supplementary. So angle 2 is involved with 1 in this given, and it's involved with 3 in this given. So I made a dynamic sketch here so we could demonstrate it, and I do have the actual addition problems right here showing that we have supplementary angles 1 and 2, 2 and 3. Our goal is to conclude and to prove that angle 1 is congruent to angle 3. Alright, let's get started. State the givens. We can start to do some abbreviations as we get accustomed to different words and definitions and theorems. The sum of angle 1 plus angle 2 is 180. The sum of angle 2 plus angle 3 is 180. Definition of supplementary angles. Since 180 degrees equals each sum, we can conclude that the sums equal each other. Substitution. Subtract the measure of angle 2 from both sides. Subtraction property of equality. And since the measure of angle 1 now equals the measure of angle 3, then angle 1 is congruent to angle 3. That's the definition of congruence. And again, we have proven our conclusion. Alright, our last proof for this video is proving the congruent complements theorem. This is on page 112 in your book. We are given the following information. Angle 1 and angle 2 are complementary. And I have a dynamic sketch here showing that measure of angle 1 plus measure of angle 2 is 90 no matter how I adjust. Alright, we're also given that angle 2 and angle 3 are complementary. So these two angles also have a sum of 90 no matter how we adjust these angles. So I'm trying to prove that angle 1 is congruent to angle 3. Let's start with listing the given. Angle 1 and angle 2 are complementary. Angle 2 and angle 3 are complementary. Now let's define complementary so we can get some equations. The definition of complementary angles tells us that their sum equals 90 degrees. So the measure of 2 plus 3 is 90, the measure of 1 plus 2 is 90. Here's where we have an opportunity to substitute. So let's make a new equation after substituting. Now once again, I have an equation where I can apply the subtraction property of equality in order to achieve what I'm after here, proving that angle 1 is congruent to angle 3. So let's subtract the measure of angle 2 from both sides. And here I'm abbreviating the subtraction property of equality for this step. And lastly, if measures are equal, by definition they're also congruent. And so by definition of congruent angles, I now have angle 1 congruent to angle 3. I'll take down the writing now, and just to verify, I'll show you the measures of these angles. Show angle measures. In fact, we do have measure of angle 1 always equal to the measure of angle 3. Thanks for watching. Keep practicing.